So thank you very much
The floor is yours.
for this. This is going to be a very interesting talk. As you know, software and algorithms drive hardware, and hardware in essence provides capability to drive the next generation architectural solution to accelerate the effectiveness of the hardware. And of course, power consumption is key in all this, but the GPU, AI factories, it's all about converting power into intelligence, high margin business. So the power consumption and reduction of that is really key. It's not just the speed and performance and the architecture, but how you can do all this at the minimum energy, because that's really where the margin is going to be driven. So I'm really excited to host this panel, and I have esteemed colleagues here. Many of them I'm meeting for the first time, so welcome. I will go ahead and introduce each one of you with a short bio so that everybody knows who you are, your affiliations. I will start with Dr. Khachik Nazaryan. He's the senior director of FPGA product development at Microchip, leading silicon software and solutions across the FPGA portfolio with 30 plus years of experience in Xilinx, Tabula, AWS, and cloud database startups. He brings deep expertise in FPGA, machine learning and AI, and cloud computing. He is the recipient of Xilinx Ross Freeman Award for Innovation and holds 8 patents. Welcome. Our second panelist is Khachik Nazaryan. Khachik is a technology leader with over 2 decades of experience in software engineering, spanning electronic design automation, cloud infrastructure, and large-scale cloud operations. He's currently an engineering director at Broadcom, where he leads a global team across multiple geographies in the VMware Cloud Foundation division, driving high-velocity, enterprise-grade software delivery at scale. Welcome. Our third panelist is Deputy Minister of High-Tech Industry of Republic of Armenia, Mr. Ruben Simonian. Has over 20 years of professional experience in the field of technology. He holds a PhD in technical sciences with specialization in telecommunications and innovative engineering technologies. Dr. Simonian oversees the work of the ministry's division responsible for developing high-tech strategies, implementing sectorial programs, fostering the startup ecosystem, and strengthening collaborations between universities, government institutions, and the private sector. He is also actively engaged in developing Armenia's high-tech strategy with a strong focus on advancing data center infrastructure, semiconductor technologies, and cutting-edge innovation projects. So we have 2 more. Enno Vin, great to see you again. I have not seen Enno for 20 years. He's a German-born technologist and entrepreneur, best known as the co-founder of Instigate. He was early believer in Armenia's tech ecosystem, also known as Instigate Design in Yerevan. Before founding Instigate in 2005, he served as CTO at Monterey Design Systems, bringing deep experience in ASIC, EDA, and embedded system designs. At Instigate, he has helped build cross-disciplinary engineering firm offering design services in electronics, software, and computing. Welcome. And our final panelist is Amit Gupta. He's a technology executive serving as corporate vice president at AMD with over 2 decades of experience in the semiconductor industry. He has led large-scale global engineering teams and driven innovation in both software and hardware. Before joining AMD in 2022, Mr. Gupta was the Vice President of Software Engineering at Xilinx, AMD, which is acquired Xilinx in 2022. In that role, he spearheaded the development of the Vivado implementation suite and established an R&D center in Armenia. He holds Masters of Science degree from University of Massachusetts Amherst and a Bachelor of Technology from IIT Kharupar. Yeah, almost close enough. Okay. Well, welcome all, and thank you for joining us for this exciting. Well, let's kind of start setting up the stage for a more deeper conversation. So I'm going to start with Rajiv. AI evolution increasingly depends on advancing hardware. Why is the convergence of semiconductor and AI so critical right now, and what is driving this acceleration?
What's interesting about AI is that it has taken 50 years, but it has come instantly. From the original perceptron model and so on. Right now, the problem is the size, the complexity, and the customization that AI needs right now. The problem, that's fundamentally what's going on with AI. The size of the problems, the data that you have to deal with, and the speed with which you have to answer questions or the solution has to be made. You pointed out about the power aspect of it. These are all areas where algorithms can help, but not as fast. Semiconductors basically are the primary vehicle to make sure that these things can be addressed at scale. So that's primarily the reason why this convergence of AI and semiconductors is very important. And the other interesting thing that's going on right now is, why is it now? Because AI is a very broad term, and in fact, if you look at originally, started with GPUs, but now every company's got a different GPU. Fundamentally, it's the same calculation that's going on, but the models are just slightly different. And because of the scale, you have to come up with a lot of different kinds of semiconductor chips to deal with the complexity. One of the key things about I see with semiconductors and AI is that they have to solve the compute wall problem. Things are still too large, and we can't handle that. Power wall, memory wall. Moore's law not helping at this point. So that's where a lot of the research is in architectures, in semiconductors, are basically going on from that point of view. And that's why you see a lot of resurgence in hardware companies. You look at VCs who are investing in this place, there's more chip companies being invested in today than in my lifetime. And that's primarily the reason.
I completely agree with you, because the industry goes through evolution where your software requirements, algorithm, intelligence now drive new architectural innovation that requires new startups to provide that. And now we have, as you said, so many different GPUs with so many different GPU memory architecture. I come from the memory world, so I understand the memory landscape's changing so fast and so challenging. Amit, what's your take on that, in terms of how can you scale this new convergence, and what are the challenges?
So the convergence between the semiconductor and AI. So one of the things that, first of all, thank you for inviting me to the panel before I get started on that. I think semiconductor is one of those fields where we have abundance of data. And if you ask me today, I think we are not using that abundance of data as much as what is needed by the industry. I'll go from I'm a software background, but I've worked in the hardware a little bit as well. I'll go very low level onto that. When you look at the manufacturing process, there is a large amount of data that is produced either at the wafer scale, or when we do the test and measurement, or if we look at the whole industry-wide verification. And one of my dreams, if you talk about the semiconductor, is to shorten the semiconductor cycle. And today, even for the best of the companies, AMD included, it takes us around 18 months to spin out from a concept to a chip. And what does it take so that we can actually manufacture a chip in 12 months, 6 months, or 3 months? And the kind of revolution it will bring in computing, the kind of revolution it will bring in AI, And what is needed really is to harness this data at the source and deploy it so that we can really shorten the cycle of semiconductor manufacturing. And be it reducing the defects, be it reducing the verification cycle, be it reducing how much does it take for us to manufacture a chip. And I think that's the convergence that I'm really looking forward to. And I think there are a lot of companies who are actually working in that domain as well.
Thank you. Shifting to Khachik, we're going to discuss about Armenia and the home of R&D, engineering resources. You at Broadcom have been involved with Armenia for 25 years, if I remember correctly, since the days where Al came in.
I wish so.
What factors does make Armenia attractive for semiconductor engineering? And I know your background is not semiconductor, but I had to ask you that since you also represent Broadcom. So,
Oh yeah, I wish VMware was here 25 years ago. No, they came here only 2 years ago, and it happened through an acquisition. VMware was here like 15 years, so they acquired VMware and they appeared in Armenia. Of course, it wasn't, I can say, in case of VMware, that was not an accident. I think Al is somewhere here, and I guess you also, Adam, participated in Integren that VMware acquired and appeared. And you might be able to answer better than me. Definitely it was talent. So they came for talent, and Broadcom came accidentally in a way through acquisition, but it's already 2 years they are here and they are staying. And by the way, right now I came to do the first hiring after acquisition, which means they are going to grow. So it's a talent, Adam, so that's the first thing. Another is, I don't know it's a culture or not, but it's a retention, which is quite important in case of semiconductor because cycles are too long, as Amit said. And if the talent is not sticking around for long, that's a challenge probably. And we have it here. The retention is quite good here. So those two, and I think there is a time zone thing, which in the case of US, a little bit of a challenge, but on the other hand, we are very close to Europe. And if it's a global company, being here in the region, close to East and close to Europe is also a big thing. But the primary reason why they came and why they are staying is talent, definitely.
and this follow-on question to that, and I want you also need to contribute to this. How can we move Armenia from engineering hub resources to more where engineers can start designing new products, coming up with new architectures? I personally believe we have all the elements to do a chip design because we do have the EDA, we do have the IP infrastructure, we do have all the components, verification, to do actual chip design, but I have not seen an emergence of an Armenian chip design company. And I think for national security of Armenia, this will be important. And I'm still waiting for one of the companies or a startup, maybe from one of you, to start thinking in this direction, because there are lots of opportunities and also will enhance the ecosystem.
I think the mindset shift is happening. The conversations are now happening more often than before, that we are kind of getting closer to that. I would recommend to look at the semiconductor a bit more deeper and understand that now chips are much more modular, and modularity decreases the level of entry basically, yeah? And you know memory really good, Adam, so memory interface, or maybe if not a design, maybe a verification lab could be a starting point.
It doesn't have to be all of it, can be gradual, right?
It can be gradual, yeah. Or interconnect. Something smaller and simpler to start with, and then build on top of that, yeah.
And what's your take? You've been doing this for 25 years in Armenia right now. Of course, you're not just focused on chip design and semiconductor, but...
Yeah, thanks for having me as well. Yes, officially, of course, originally I've been a hardware guy. So basically, the question about how to make hardware intelligent, I would first of all take as a personal insult because hardware was always intelligent.
Yes.
It was software that was not. But of course, actually there is no more hardware and there is no more software, because even if you take a piece of hardware, let's say a hard drive, which is about as hardware as it gets normally, there's already 3 levels of firmware inside, which are in fact software. So basically there's the distinction between the two doesn't exist anymore. I mean, it has gone away many years ago. So we have to, when we talk about one, we also have to talk about the other, and we basically have to develop both of them at the same time. There's just no other way.
Mr. Simonian, you can give us your perspective from government policies, what the government can do to shape Armenia's next chapter in this evolving and fast accelerating world of convergence of hardware, software with AI driving this revolution.
Thank you. First of all, I agree that today thinking about the hardware without software is very difficult because both are very important. If you will look into the vehicles, nowadays vehicles, there are 80% are the components, electronic components with software inside. So what we are doing right now, I think that the main challenge is the talent pool, is the talent pipeline. Yeah, we have very strong, very ambitious engineers, but we have to move forward with the quality of education, and we have to improve the collaboration between industry and universities through maybe technology transfer offices. What we are doing now, we're forming and we're developing the high-tech strategy for Armenia. And right now we are in the stage of mapping the education, the programs that we have in universities, with the needs of industry. And for example, we have 14 technological streams, and we're mapping those streams with the needs of industry. For example, just yesterday, I asked my colleagues to provide with the data how many engineers in 2024 were provided which may contribute to the semiconductor industry. For semiconductor industry, you should know today artificial intelligence, of course, ML, cutting-edge technologies, microelectronics. And for the last year, we had about 13,000 students pass through these programs. But we have to focus more on the fundamental knowledge, because again, when we are talking about AI, that means that the productivity will increase maybe 20 or 30% even in semiconductor supply chain. And the domain knowledge which is related to the microelectronics, physics, chemistry, so that should be improved in all countries. So domain knowledge is a critical piece of this journey. In Armenia now, you know that we have signed an MOU between US and Armenia, and technology which includes semiconductor and AI is the highest priority there. So we're trying to open access to the cutting-edge technologies for the Armenian companies, and we're trying to. First of all, I would like to say appreciation words to all multinational companies, semiconductor companies that are here, because it's not so easy to keep growing. And thanks to the site leads, thanks to you, we have now these companies in Armenia. And if Broadcom came through acquisition, if Synopsys came through acquisition, now we have Armenia in the landscape as a semiconductor country, which mainly contributes to the first phase of semiconductor supply chain, which is chip design and verification. And here we have strong knowledge in industry and in universities. We have to think about the next step It's not so easy to bring like the backend fabs, because all these companies actually they are fabless companies which are presented here, and they are like the TSMC for working for them producing the wafers. They are fabless companies, and it's not correct when we are asking someone what shall we do else, and when they are saying we would like NVIDIA to bring the manufacturing to Armenia, or Broadcom manufacturing to Armenia, or AMD. Guys, they are not doing manufacturing. They are in R&D and innovation. And that is what we have in Armenia. We have innovation and R&D. So we are going to support more investments into the R&D. We are going to support more into the education quality related to the semiconductor and AI, microelectronics. We are going to create more relationships with other countries which are strong in this field in order to open the access to the technologies. We are going to simplify, we are working on simplifying the import and export policies and procedures, because that is crucial, that is very important for our local companies and multinational companies to operate and to expand their businesses here.
I thank you. I couldn't agree more with you. Really, we're not in position in Armenia to open manufacturing factory here. We're like years and years away, but I think the next logical step is to strengthen what we have and also move one layer up in terms of doing design innovation and products that we can outsource manufacturing to the different excellent centers around the world in terms of kind of adapting the fabless semiconductor model. So from that point of view, I think that should be, in my view, the next focus and the next program. We also need to think, I believe, about how can we attract non-Armenian scientists to come and work in Armenia, because there's a gap. Until our education reform goes through for the next 10, 15 years, we have a gap, and we cannot produce enough technical talent in Armenia, so we need to borrow that talent from elsewhere. So we need to come up with a program where non-Armenians would like to come and live here and work in this field and mentor the next generation while we start indigenously growing that. So I think this is something we should seriously think about. So
I totally agree with you. So we have this legislative package, and we're trying to motivate also labor migrants to come to Armenia and to contribute here. But this is not enough. So our focus should be also on joint research programs with other universities. And again, within the high-tech strategy, this is like the very important pillar that we have to focus on the collaboration starting from the universities. And again, we have to establish strong technology transfer offices in order to bring scientists and students closer to the industry through joint projects, through joint R&D. So, of course, this is our focus as well, to bring competencies from abroad.
thank you. We're going to shift gears now to hardware meets AI. So, Amit, I'm going to start with you. After decades of Moore's law, giving us performance at the cheaper prices, now we're at a stage where it's become quite expensive to go to the next node. So there are new architectural solutions with chiplets, heterogeneous systems, and etc. What technologies will define the next decade in AI, in your view?
So next decade is a long time, and especially you heard the other keynote talk. I think lots of things are going to change maybe in the next 3 to 4 years. So yeah, like you mentioned, the chiplets are here. The AMD, for example, the whole portfolio is based on chiplets. And the heterogeneous compute, you see it everywhere. There are CPUs that are really good at doing a class of AI problems and non-AI problems. There are GPUs. And then from AMD and the other companies, there are domain-specific accelerator as well. But coming to your point onto that what is it that we see in the next 10 years? And in my view, the next 10 years, we are going to see a big revolution on 2 areas, which is robotics and industrial automation. And you heard a little bit about AI factories earlier as well. And what is needed in robotics and industrial automation is a compute that is really geared towards this. For example, the robotics application, they are very battery sensitive, power sensitive. If you take a CPU or a GPU and apply to that, you're not making a good use of that compute and you're running the battery out quickly. So with that context, that if 10 years down the road, the biggest market, the biggest revolution that we'll see is black factories and robotics, I think the domain-specific accelerator is really where A, a lot of investment needs to go in, and B, the sharpest mind in Armenia can really think about it. What are the applications that are going to be built in future in that domain, and what kind of a domain-specific accelerators are needed in that?
Rajiv, we're going to now talk about the balance between general purpose and specific purpose architecture design evolving, especially between data center, the edge, and what are the views on that for the next, let's say 5 years. 10 years is a long time.
So a lot of what people hear in terms of AI is almost at the edge. You talk about GPUs, a lot of the stuff, data centers, people are building, data center economies. I just saw something that said that the data center economy in the US was 3% GDP. So the rest of it didn't have a whole lot. So the point is, people talk about that, but the real innovation is going to be there at the edge. Data center is going to happen, and a lot of the hyperscalers are basically going to be working on the data centers, and they will have different kind of architectures for different workloads. Meta is going to have a different kind of a workload. Amazon's going to have a different kind of workload, and so on. But the key innovation I see is going to be in the edge, primarily because everything that you have today in electronics, every piece has an AI, something to do with machine learning or AI. And you can either go use a general purpose if it's not enough volume, or you go with, as Amit mentioned, domain-specific stuff. So there's going to be a big push to get more specific architectures on the edge, where power is going to be very critical. You cannot have a fan. You need to be able to. I met a startup here that was doing some sensors for 40 years in a building, right? That's the kind of power, and they have to have some intelligence in there. So I see a lot of specialization, and that's where I'll go back to Minister's point about innovation. The point is not about trying to chase the latest thing, but it's get the fundamentals, because the innovation will happen based on what the requirements are. Robotics, whether it's medicine, whether it is just general communication. There's a lot of specificity, and I see that that's where the difference is going to be, and that's where I see a lot of value.
Yeah, I think Amit, earlier you mentioned about, I agree with you, but the edge-driven innovation. So the problem really when the rubber hits the road is like, how can you scale different architectural solutions with different software fast enough to be able to fulfill the innovation that's driven from the edge? And that to me is really the big question. It's not just about a new semiconductor technology. It's a combination of that, plus new platforms like chiplet and others, plus new software algorithms, new architectures, but all this complexity has to happen in real time. And to me, I don't know who's doing this, and I think whoever can figure this out will be really the next giant in this area. But it will be very specific. But I can imagine methodologies evolving, companies coming up with architecture that as an EDA tool or platform that can enable the next architecture revolution. So, Khachik, as software increasingly shapes hardware optimization, what promising frontiers do you see in AI-based chip design?
Oh yeah, Eno I think talked about that. I think Eno is talking about that for last many years about hardware software co-design. I think, and others talked about other innovation opportunities. What I believe is in that now, I mean, tweaking hardware to work for any model in this world, I don't think it's practical. You can get a little bit closer, but making sure that the compiler, the kernel, and the whole model and the hardware, they work together, that's called hardware software co-design, and I believe in that optimization. And by the way, Armenia itself has an opportunity there because the entry point is a bit easier. So seeing a neutral verification lab, neutral optimization lab here, that helps internationals to come and use those labs to optimize the model on top of every hardware possible. I see there a big opportunity there. Because it doesn't really require any specialized hardware to have, and it's just about a strong math background and computer science and the good software knowledge. So if we combine those together, this hardware software co-design and the optimization so that models work for a specific hardware much better, which means like reducing the memory interface, data movement, making sure that the interconnect and the scheduler works much better. I mean, I go into too much maybe technical details, but Armenia is a big opportunity there.
Do you see someday AI helps you design hardware as it is now replacing software engineering? I mean, I never thought this would happen in my lifetime, but
I'm not a hardware guy, but designing hardware is, maybe I take it too easily, it's done through software anyway. Yeah, the initial phases and the simulation is happening within the software. And yeah, I mean, why not? All the initial phases up to the time that you reach the real tape out. And specifically, I keep saying verification, I see a big opportunity here. Yeah, verification deals with so many variables and so many permutations that I don't think we ever solved that problem with classic algorithms anyway. And now AI is I am sure, is giving a big opportunity here.
Mr. Simonian, you want to add to that?
Yeah, and for example, in chip design and verification, so you have to create test scenarios to find the bugs, etc., through different like math models or simulation. And if you will use AI during the verification, so instead of manually creation like critical test scenarios, AI might help you, which means like it means that the time decrease and cost, of course. So here, and I totally agree with Khachik that Armenia has a huge potential in maybe in positioning Armenia as a verification, test and measurement hub, and chip design. So you know that we have that competences, for example, and we have a platform for emulation and verification from Siemens, Velocistrato, and we have advanced research labs here in Armenia, in aerospace, in automotive, in semicon, IoT, and we have master programs. So we have to leverage all that we have that capacity. And what is important here, that all these corporate companies, multinational companies, they also brought the knowledge and strategy for the upcoming 10 or 20 years. And the next idea should be the following. They have to bring the problems, and we have to give these problems to our research institutes, to our universities, for them to resolve and to provide solutions. This will be the exact and the best way of bringing these all parts together.
Thank you. Eno, I'm going to ask the next question to you. You know, Armenia, thanks to your help, kind of created strong and earned global respect in terms of engineering talent. As we look into the future, what new skills and capabilities we need to cultivate so the Armenian engineering talent can meet the challenge of AI intersecting semiconductors. That could be from system level design to AI model optimization on hardware.
Yeah, so we've been talking about innovation, a lot, and I mean that's a usual subject to talk about. And I think the question is, when does innovation happen? Does innovation happen when somebody gets told to innovate something? Probably not. Innovation usually happens from the ground up. Innovation usually happens when somebody doesn't follow the rules. And I think there Armenia is particularly strong, not following the rules.
Not many people follow the rules.
Exactly. That's actually one of the strengths. So basically, I think Armenia is very well set up in principle to innovate, and that kind of mindset has to be fostered and has to be pushed in innovation specifically. In education. So it has to be pushed more further. It's already the case, but it should be pushed more that education, kids and young people and engineers learn to basically not just necessarily follow the rules, but actually think and think out of the box. I mean, how did Google train the best chess robot in the world a couple of years ago? Not by teaching it how basically the famous chess players used to play. No, it just taught it by basically playing against itself. That, to me, is basically the epitome of thinking. This is thinking. People need to be taught to think. And then basically they will start to question rules that don't make sense, and they will start to understand that there are, of course, some rules that cannot be broken, let's say the laws of physics, and they learn to distinguish between the two, and then they can actually start innovating in a meaningful sense without just creating havoc, basically.
You're so right about Armenian engineers not following the rules. It's not just about the engineers. You know, as you know, I make wine in Armenia now. Even I have a consultant in the US. He gives very detailed, specific rules, but the local winemakers will not follow, and then it has to repeat and repeat.
And there's good wine.
Yeah, it works. Same true in wine as well. Khachik, if you could describe the next generation Armenian engineer that doesn't follow rules, what blend of skills would make them globally competitive?
Oh, I hope they at least start following the driving rules. So I hope I was not referring to that. Look, I want to see an engineer who is ambitious enough to believe that there is we can have an IP in design. That's what I want to see. Basically, first someone who dreams about having a design IP at least locally, and then another is believe that we can have. I keep saying it's a very practical thing, and the deputy minister is sitting here, and his background is from semiconductor too. That someone who believes that in Armenia we can have a neutral verification and optimization lab. I truly believe in that. So I would want to see an engineer with that kind of an ambitious dreams, first of all. And of course I agree with someone who is willing to break the rules and disruptive enough. I don't want to say with someone who has some specific knowledge. Nowadays that's easy to gain. That's someone who is ready to disrupt the rules, don't follow them, dream that we can have an IP. I mean, everyone is questioning in hallways conversation. The moment we talk about a semiconductor, in Armenia everyone thinks about manufacturing. Of course we are not talking about that, but we want to have some local IP. And those modular chips are allowing us, I mean, there are many chiplets. Some chiplets are not that complex, I think, yeah? Who is preventing us to have a couple of IPs, let's say, I don't know, 5 years from now, here locally. So I want to see that kind of ambitious engineer.
Do you think the problem is because our engineers are not close to the market, or the end users, that doesn't help them to come up with innovative solution for specific chip functionality?
I don't think so. I think being on a more or less service role and earning enough in a way, that keeps them in more or less a relaxed mode. So I don't see that who's ready to dream even bigger. I mean. Not enough, I mean, yeah. As I said in my previous answer, I see the mindset is shifting, so the conversations are happening. But maybe there should be some natural pain or whatever, so that because that service role that they are serving now, it gives them enough not to think about beyond that.
Basically, they're very comfortable.
Yeah, so
they're not pushing
something
their
should
intellect
push them
hard.
out of comfort zone. And maybe if more international come, or I mean, the labor market is small anyway, so they will have to compete.
This is a good segue for Mrs. Simonian. The next question I have is, what are the most effective ways academia, startups, multinational R&D organization can collaborate together to shift the mindset from excellent in engineering to become innovators, designing new products and new capabilities?
So I think that the like institutionalized way is, again, as I mentioned, is creating the strong TTOs, which will connect the corporates, multinational companies, local companies to universities. For now, almost all companies in Armenia, big companies, they are already collaborating with universities, because you know that in 2022 many companies came to Armenia and many migrants came to Armenia, but they starting like, it was like for short time, so they're starting to leave Armenia, because Armenia was like the place where they had to understand, to stay a little bit, and then to understand where they would like to go. But that was a good chance and opportunity for Armenia to transfer that knowledge to Armenian engineers and to universities. At that point of time, so Rev was here, and I had a discussion with Rev and with his team while I was at National Instruments, maybe 3 years ago. Said that they were looking for very senior engineers and architects, but it was a problem. What they are doing now, they are working with universities. They are bringing juniors, they are bringing students, part-time, then full-time, but they are becoming the very loyal employees to this company with the culture of these corporate companies. And then they are spreading this culture with other teams. And it might bring also to the spin-offs from these semiconductor companies. And we had that experience with, for example, with National Instruments. We have many companies in Engineering City where the leaders are former NIRs. And of course, all they are focusing on FPGA, on embedded programming, etc., etc. So this is engineering. But again, we are working now on bringing expertise and competencies for building strong technology transfer offices in order to help our industry and to help our multinational companies and local engineering companies to grow up and to be like, not to be nervous about the strong talent pipeline in Armenia.
Yeah, I completely agree with you, Mr. Simone. We had the same challenge when I was here with Virage Logic, early 2000s. We could not find any talent that knows semiconductors, so we had to retrain them, and we did the same, got young engineering talent, spent 6 months training them before they really start working for the company. And I think Synopsys has similar program. It's very, very successful. When you start early on and mold that talent into the specific area you're trying to get experience, then they become loyal, they're continuously learning, they're improving, and at the same time the company's benefiting, they stay loyal. So I think there is no specific, I always, when I hire people, I don't hire experts, I hire people that can think, can become expert, because this expertise changes every year, every 2 years, and you need people can think independently. So that's really a key in my view. So I agree with you 100%. I want to shift back to you in terms of, should Armenia kind of stay focused on providing EDA and design services, or start thinking more in growing into higher architecture level solutions that meet the new era of AI hitting semiconductor, both in memory. I know it's really a difficult shift because sooner or later, this service engineer may not be needed. So I think the pool of engineers that exists today needs to upgrade their talent level to be able to really start operating at a higher level. So how do you see that transformation happening in your view?
That's actually, yeah, that's quite difficult. What I think I'm going to say is relatively controversial. If I haven't succeeded so far with this, I think we have enough technology in the world right now to cause big problems. Specifically AI, let's say, or what we call AI. I mean, it is not actually intelligent, right? I mean, we all know that. We just call it AI. But it's already super powerful. And as Rajiv said, it happened instantaneously. Nobody really was aware of that happening so suddenly. And we're struggling to deal with this. And I think mainly the society struggles dealing with this in a big way, and basically being able to actually live with this new challenge of something that is just completely unheard of in history. I mean, basically, even let's say something like the car was just an evolution over the wheel and the horse and so on. But an actual artificial intelligence is really something new. Something that is potentially intelligent, but probably not conscious. And of course, it would be easy to make the joke. Let's say this is the race: who gains consciousness first, AI or humanity? But I would say it's important for humanity to gain a consciousness on how we use this. And so one of the things that has to happen is that it has to be democratized. It has to basically be given into the hands of people. They need to be able to own this, to use this, and to use it for their advantage, and not basically the other way around. That it's a top-down thing that, let's say, 3 or 4 people in the world really benefit, and the rest gets left behind. And I think that is actually something where Armenia can lead, in fact, the world, basically in an ethical way of trying to basically innovate here and deal with this.
Yeah, that's an interesting thought. Requires another panel for that. Yes, please go ahead.
If I add to that thing, I think that's right, that how do we move from the EDA or the IP design to an architectural thing. And this is, I think, where we need to get ahead of the curve to use AI, like it was just mentioned, to do the architecture exploration, to get more trained in that field so that it can provide that new IP and new architectures to the rest of the world as a technology. So rather than going through, developing a perspective that we can do an architecture exploration, use what's available in the market and in the technology to drive that.
So we're going to go through kind of closing remarks right now, and as we're running out of time. So this is open to all of you, so you can go whichever order you like. If we meet again in 2030, this is 5 years from now, not 10, what success story would make you say Armenia has become recognized leader in intelligent hardware innovation? Mr. Simonian?
Yeah, I would like to be more specific here. In 2030 or even earlier, I would like to see, like Rev presented the last slide, with brands that are presented in Armenia. I would like to see 2-3 slides, but there is a goal for myself to bring several companies and to extend the existing companies in Armenia. I can say that I will succeed if I will see ST Micro, analog devices, I make Texas Instruments in 2-3 years here in Armenia.
Thank you. My association with Armenia goes back to 2008, where I was working with Instigate Design. Some of the things that I heard, I think 5 years from now, we are here. I think the talent is here. We as a microchip are one of the few companies that actually have almost 20% of our people that work for us are interns from rail school. They do fantastic work. So I think the talent is there, and then this whole idea of service people and do what you need to do. We have actually turned the operation into, we started with software design, we started with EDA. We do solutions, we do board design, we are working on silicon engineering. We have chip design here on our next generation architecture. So we have a lot of different areas that we do here, and they're actually responsible for it. They're not part of a bigger team and just doing some work here. They are actually owning pieces of it. I see there's one thing about Armenia that has happened, which is the fact that necessity is the mother of invention. You're a small country, and there's a lot of innovation here, and there's a lot of drive. That's what I see here. I think that's going to, the sky's the limit.
So you expect in 2030 some of your engineers doing complete chip design in Armenia, right?
We are already doing it today.
Fantastic. So you made my day.
Yeah, I would say in 5 years to dominate the hardware design. I'll come back to the previous point I made, which is give something to the world that the world needs right now. And one thing that the world's need right now is how to shorten the design cycle. How do I get to manufacture chip? How do I get to write software for domain-specific accelerator, for example, not in 1 year, but in 6 months? And that opportunity is there. All the tools are available in the market. We have to innovate. The engineers here have to innovate and find a way that how we can give to the rest of the world. Don't spend 18 months in fabricating a chip, spend 3 months. And in 5 years, we can achieve it. What's needed is the right mindset, right drive, and right motivation.
Thank you.
In 5 years, first of all, it would be a great success if we're still here. Secondly, we should have, and I'm not talking about specifically only Armenia.
I see, generally.
No, yeah, I'm thinking
You're that pessimistic.
I'm thinking about the ark, the flood and the mountain and all this. No, seriously, we need to be, as a worldwide society, we need to be in a situation where most people can comfortably use AI for their purposes. And that basically the AI is there to serve the people and not the other way around, that the people actually have to fear the AI, which is, I think, a lot happening right now. Many people are basically, I hear that from a lot, that people are actually worried about it and are declining to use it and so on.
So I think usually it's the case, you worry and you fear things you don't understand, you don't know. So I think as AI penetrates more into society, I believe more and more people will feel comfortable. We can understand it more. I think that anxiety to a certain degree kind of subsides. But the bigger question, I agree with you, that we don't have a specific solution for. So you want to add something to that?
So it's an interesting point that he brings, but I see a lot of parallels between when calculus showed up, it changed everything. And at that point, people were like wondering, what's going on? What do we deal with it? But essentially, we mastered it. We figured out what it was. I see AI as a way to solve problems, not something, I know we're talking about consciousness and all of that stuff, but fundamentally, I see AI as another tool to solve our problems. And that's the way I think we should start looking at it.
So we have an optimist and pessimist. Khachik, you want to?
Yeah, let me close on a positive. Yeah, 2030, I have two things that I want to see. One is more personal, but I'm sure everyone will help me so that Broadcom is here not only for former VMware part, but one of their semiconductor franchises is here. More specifically, I would want to see their interconnect franchises here. And the second is, as I keep saying, I want to see a neutral verification lab, which is trusted globally. All those big guys come to test their models here.
So are you thinking about formal mathematical methodologies to guarantee that? Is that part of that equation?
Oh yeah.
Do we have enough
mathematical models, especially using AI, and most likely, because that's a new thing. I mean, all the traditional methods are there, and I don't think those big guys can shift those things fast. We have that opportunity window now. It's a new type of verification model.
Thank you, Khachik, for this. I think we're done with the panel. Does anybody wants to say something they didn't have the opportunity to say? Do you have 1 minute?
I'm not a
We're not breaking
pessimist.
the rules. We still have
You're
1
not
minute.
a pessimist, so my apologies. I didn't mean to say that you're a pessimist, but I thought you were by some of the comments you made. Well, thank you, gentlemen. It's been an honor to moderate this panel with you. As usual, we'll learn from each other, and I have learned the most. So thank you very much, and thank you for listening.